So what is scientific notation? Well, let's say we have a pretty big number, like 9, 8, followed by, we'll say 7 zeros, 5, 6, 7, right? And we have this really big number, and we're going to have to write it a bunch of times, but we don't want to have to write this huge thing out a bunch of times, right? Scientific notation is what we use to condense this, okay? So how do we do that? Well, what we're going to do is we're going to put this number in the form a times 10 to the power of b. And you'll understand more about what that means in a moment, but that's the form we're putting in it. And we have the rule, a must be greater than 1 and must be less than 10, okay? So I'm going to do this example here. What we're going to do is we're going to put this in scientific notation. So what we're going to start with is recognizing what could our a value be. Our a value is going to be 9.8, okay? And this will make more sense to you in a moment, right? 9.8, and then it's going to be times 10 to some power, okay? So how do we figure out what that power is, right? Well, so what we need to understand is the decimal for this number is right here, okay? And we're going to move this decimal over 1, 2, 3, 4, 5, 6, 7, 8 times to the left to get the power 8, okay? And we moved it there specifically because to get 9.8. If we moved it right here, we would have 0.98, and 0.98 is less than 1, therefore not being in scientific notation, right? And then if we moved it right here, it would be 98. That's greater than 10, right? And therefore not in scientific notation, right? So we have to understand we're going to put the decimal point right there, and we moved it over 8 times to the left specifically to get this right here. Okay, let's do another example. Let's say we have 625 followed by 5 zeros, right? And we want to put this in scientific notation again. So I encourage you to figure out where we might put the decimal here, right? So just think about that for a moment. Okay, now hopefully you determined that the decimal should go right here, and that will give us 6.25. So this equals 6.25 times 10 to some power. Now once again, let's figure out how many times we moved over that decimal. Started here, we went 1, 2, 3, 4, 5, 6, 7. We moved the decimal over 7 times to the left, so it's the power of 7, okay? Now, scientific notation can be used to rewrite really big numbers, but we can also use scientific notation to write really small numbers. Right? So how do we do it this time, right? Well, once again, the rule applies where a must be between 1 and 10, right? And in our case, the a is going to be 7.3. 7.3, right? Times 10 to some power. Now, once again, we have to figure out what that power is. So we move the decimal point over 1, 2, 3, 4, 5, 6, 7 times. So it's the power 7. But we didn't move it over 7 times to the left. We moved it over 7 times to the right. When we move it to the right, it's going to be times -7. Okay? Let's do another example. Let's say we have 0.0003, right? Well, in scientific notation, our a is going to be 3, right? And the decimal, we'd have moved it right there. All right, so times 10 to some power. Well, we moved it over 1, 2, 3, 4 times. So 4, but we moved it over to the right 4 times, so it's times negative to the power of -4, okay? Now, let's think about what would happen if we needed to multiply two numbers in scientific notation. Let's say we wanted to multiply 3 times 10 to the third, right? Then multiply that by 4.2 times 10 to the fourth. How do we do this? Well, what we're going to do is we're going to multiply these two parts together, and we're going to multiply these parts together, okay? So we multiply 3 times 4.2, we get 12 6.6, okay? Then times 10 to some power, right? Now, what's that power going to be? When we multiply 10 to the third times 10 to the fourth, we multiply exponents, we add them together, okay? So this will be times 10 to the seventh. But you might notice a problem. This 12.6, that's not in scientific notation form, right? Because it must be between 1 and 10. Okay, so we're going to rewrite this as we're going to move the decimal right here. So 1.26. And let's notice this. We're decreasing this by 10, so we must increase this by 10 for them to be the same number. So it's going to go from 10 to the 7th to 10 to the 8th. Okay? Hopefully you understood that step. Now let's take a look at dividing exponents, or dividing in scientific notation, right? So let's say we have 6.4 times 10 to the 5th divided by 2 times 10 to the 3rd, right? And we want to figure out what that will be. Well, we're going to divide these two numbers, and we're going to divide these two, right? So this will be 6.4 divided by 2 is 3.2. Then we have times 10 to some power. What will the power be? When we have exponents and we're dividing exponents, we're going to subtract them from each other. So it's going to be times 10 squared. And that's our answer in scientific notation. Now, the last two problems we're going to do is going to be focusing on adding and subtracting in scientific notation. So let's say we want to subtract 3 times 10 to the 3rd minus, let's say, 2 times 10 squared. Now, what we can do here is what we can either, so here, let me give you some understanding what we're trying to do here. If we have two numbers, like 3 to the x minus 2y, we can't subtract these from each other, right? But what we can do, what we can subtract from each other, is 3x minus 2x. So what our objective is we can think about these 10 to some power as that x or y, and we want them to match each other. So let's focus on this one right here, okay? We want to make this from 10 cubed to 10 squared. So this is going to be times 10 squared, and we made this smaller by 10, so we're going to have to make this larger by 10. So it's going to be 30 minus times 10 squared, right? Then minus 2 times 10 squared. Then, just like we would subtract 3x minus 2x, we're just going to subtract these two parts from each other and leave the 10 squared. Or another way we can think about it is factoring out the 10 squared, right? And we get 30 minus 2, okay? So then from there, we just get the 28 times 10 squared. But just like last time, you might notice that this is not done. We're not in scientific notation, right? Because this is greater than 10. So we have to take the decimal from here to there, which is going to make it 2.8. And we decrease it by 10, so we have to increase that by 10. So it's going to be times 10 cubed, okay? And that's our final answer. So now let's do one problem with addition. So let's say we have 6.4 minus, 6.4 times 10 to the 4th minus 3 times 10 to the 5th. Okay? How do we do this? Well, what we're going to do, just like last time, this is not minus, we just did minus. We're doing adding, okay? Just like last time with subtraction, we're going to make the powers of these equal to each other. So we can either choose to increase this 3 by 10 and decrease this power by 1, or we can decrease this by 10 and increase this power by 1. What I'm going to opt to do is increase this by 10 and decrease that by 1. So we're going to get 6.4 times 10 to the 4th plus, this is going to become 30 times 10 to the 4th, right? Because we decreased this by 10, so we must increase that by 10 in order for them to be the same number, right? Then, from there, we just add these two together. So we get 36.4 times 10 to the fourth. And just like last time, this is what you really need to remember. When you're finishing up doing some sort of problem in scientific notation, do not forget to check if your answer is actually in scientific notation. Sometimes it might look right, but it's not going to be right. Just so we have to move this decimal point over once to the left. Now we move it to the left once, therefore decreasing that by 10. So this is going to be 3.64. Then this will be increased by 10. 10 to the fifth. And that completes that example. Thank you so much for watching. Let me know if I say anything wrong or if you have anything additional to add. Have a great day.